special products. First of all, what's a product mean? That word multiply, right? So we're looking at some special multiplication. So x plus 3, this quantity squared. Before you get out like, oh, I know what it is, here's what it isn't. Not x squared plus 9. Not that thing. Not. I know, oh, come on, it should be. Okay, why not? Didn't we just do rules that said, oh, the 2 just goes with the numbers? Did we just do that?
Yeah.
So why isn't it working here? Why doesn't it work? Well, it is special, but that's not why. What's going on here? Is that the rule? Is the rule you just put the 2 on both of them?
No.
What's the rule?
You have to multiply both.
What do you mean multiply both? What does that mean?
With the war. You don't use it twice.
Yeah. Here's 9 pins. This is an arrow, and it's pointing to what?
Addition.
Yeah. Why am I
Oh, I
pointing
know.
at what?
9x squared.
What?
Would be 9x squared.
Why would it be 9x squared?
Well, you could add.
Well, I'm looking at the plus. This plus is kind of throwing a little proverbial spanner in the works here. What's going on here?
It's kind of like a
Hold
line.
on.
It would be 3x squared.
Can I add an x and a 3? Are they like terms? Can't do that. What's the rule? We kind of went through this before. What's the rule that says you can do this? Remember, what's the rule? Goes here, goes here, right? It's the power by book. What's the difference between this and this? And here's my other arrow. Oh.
It's multiplied.
Yeah. The rule works when you're multiplying. If this had said x times 3 squared, that would be x squared times 9. This is not a multiply. It's a plus. So that rule is not a rule. It only works with multiply. So don't get all excited. Oh, yeah. Don't do that. What does x plus 3 to the second power really mean? It means take this x plus 3 as a factor how many times? All right, so let's do that. Take x plus 3 as a factor twice. Oh, yeah. Oh, yeah. All right, now what? Foil again, right? So we have x times x. X times 3 is 3x. 3 times x. 3 times 3. I look at my OI. Oh, look at that. They combine. X squared plus 6x plus 9. I'm just going to put it up here so you can see it. X squared plus 6x plus 9. Okay, now we get the general idea now, right? What isn't this? It is not x squared plus 4, is it? Not. I can't just apply that too. I have to expand them out. It's x minus 2 times x minus 2. X times x. What happened? I don't know what happened. Tell me, wait.
Oh, I know.
Negative 2 times negative 2. You guys doing this with me? Because some people are like asleep. Wake up. I'm awake. All right, this next one, same kind of idea. What isn't it? It's not this thing squared plus that thing squared. What is 3x, that whole thing squared?
6x. I mean 9x.
9x squared, right? You got to square the 3 and the x. Okay, it's not this. Not that. You have to say it's 2 factors of these things. 3x times 3x is? Yes, you do. Absolutely. Yep. 3x times 3x. 3x times negative, yeah. No, you're absolutely right. And then we're going to combine the OI as we can. So be really careful with these. You're gonna, if you go in autopilot, you're going to make a mistake. So think all the time. And he's right. He said, what happens if there's, I'm going to go just with 3 here, because I don't want to write it, 10 times like he said. It does mean that.
We actually don't use the power.
Right, isn't that what that means? Take this as a power 3 times. Okay, as base 3 times. So that's what you would have to do to figure that out. When you get to algebra 2, we have some other ways to kind of work on ones like this as well. Algebra 2. Yeah. All right, so anybody noticing a pattern of any kind?
Yeah, multiplication form.
What does that mean?
Polynomial.
Yes, they're polynomials. Yep. I'm just looking for, is there a shortcut? I don't maybe
I
have
hope
to.
so. Yeah.
Because I'm looking here, look what it's not, but look, it's kind of a little bit. It's got the x squared, it's got the 9.
By itself.
Right, it's got the x squared, it's got that 4.
Oh, you have
It's kind of, but what do I have to figure out how to find? The middle piece. Now, did anybody notice something interesting down here?
Yes. Yeah, it's the same number.
They repeat how many times?
Twice.
Now, how do we get the 12, the negative 12? How do we get the negative 2? How do we get that 3? It was 3 times x, 3 times x. Negative 2 times x, negative 2 times x. Right? So what did we do? We multiplied these two things, and we took 2 of them. Right? You multiply these two things, negative 2x, and you take 2 of them, that's negative 4x. Multiply these two things, that's negative 12x, take 2 of them, that's negative 24x. So what is my general pattern? If you have a binomial and you square it, so what do? You square this guy, you are going to square that guy too. How do we get the middle? A times b, I want 2 of them though, so 2. A, b. That's the pattern. If we had a minus, it's really the same thing. Square this guy, square this with the sign, right? Negative b times negative b, so it's always positive out here. Multiply, what's a times negative b? Negative ab, I want 2 of them though. Negative 2ab. So it's a shortcut if you recognize the pattern. Now I have a confession to make. When I was like your age, and I was your age at one time.
Oh.
I was. I know it's hard to believe, but I was. And when I was learning algebra, when we got to this, I really wasn't ready for this pattern. I'm like, listen, I can barely multiply these things at this point. I'm not ready. So this is what I call a really nice thing to have. But some of you are going to be ready and say, yeah, no problem. This is this little pattern. I'm great. I don't have to do this big multiply. However, if remembering a pattern right at this point is going to make your head explode just a little bit, what should you do when presented with a problem like this instead? Make 2 factors and do the multiply. Make 2 factors and do the multiply. This will come with time. So it is okay, you're not quite ready for this yet, no problem. Just multiply them out. Remember to do it. This thing times this thing. Don't do that. Question over there? Is that you, Kelly? I add another factor, right? Yep. Use FOIL, use the multiple distribution, and just multiply it. Now, if you're great with the patterns, this will make it faster. That's all. Now, we got another little pattern here. We call this one the sum and difference pattern. How come? Because look, x2, x2, right? Same thing, except what's different? I have an add and a subtract, a sum and a difference. Well, let's see. Let's see. So let's use FOIL. This times this. That's x times x.
X squared.
X times negative 2. Negative 2x. Now I'm going to use this guy, my inside. 2 times x.
2x.
And 2 times negative 2.
Negative 4.
All right, let's look at our OI, because they are like terms. Negative 2x plus 2x. Finished. All right. Let's see. Let's try another one. So I'm going to use FOIL here. X times x.
X squared.
X times negative 6. 6 times x. And 6 times negative 6. Yeah, what's happening here? Cancels out. They're gone. Oh, wait a second. All right, and then let's try this guy. Careful. 2x times 2x. Careful.
4x.
Careful. Careful. You're not being careful.
2x
4x squared. Do 2 times 2. X times x. All right, 2x times negative 1. 1 times 2x. 1 times negative 1. Once again, look at that. Come on. All right, now this one you might be able to see the pattern a little bit easier. What is the pattern here? What's happening? Yeah, and now we're allowed to do it. What's that thing we're not allowed to do? Multiply. The first and the last, right? The oi's, the outsides and the insides will cancel out. Instead of FOIL, this is right? Except for a plus and a minus, and it's okay if it's written this way. This means the same thing, right? Right?
Yes.
Unit property multiplication. What do we get? Just do the firsts and the lasts. Because your insides and outsides will cancel out. So this one, I think it's an easier one to see. What do you guys think? Yeah. So remember how the other one was a nice to have? This is, you better know this one. Know this one. Learn this. It's important, right? We're going to be using this for other things. And luckily, this is the easier one. So let's look at, this is like just the general case. If you know the pattern, this is so easy to do. I barely have to think about it. Now, I know the pattern. I've been doing this 100 years. Well, what's the pattern? Square the first, square the last, multiply these times 2. Square the first, square the last, remembering that it's minus b times minus b. Multiply these two things times 2. Now, if we're like, no, not ready, then just remember this a plus b times a plus b and use FOIL or your multiple distribution. Now, this guy, on the other hand, same thing, sum and difference, what is it? A squared minus b squared, the first and the last. That one I want you to remember the pattern. Now let's say you don't remember the pattern. So what? Do the outside, do the inside, you'll see them cancel out. So on your paper there are 2 boxes. You see these 2 boxes? There's this one, and this is your nice to have. It's a goal to shoot for. This guy, see the second one? You're putting a big kind of circle or a box, you're putting something around it. This is important. You have a highlighter, it's a great thing to highlight. You need to know this. And luckily, it's the easy one. I think this one's easier. I recognize it, I see it. So let me show you what I mean. So on these practice ones, like I can do these really fast. Because what am I doing? I'm using that pattern. I hope I'm doing it right. I'm using the pattern. Square the first, I can even go that way, square the last, multiply times 2. Do I expect everybody to be here at this point? 60 and 4. I'm doing it right, first of all. No, I don't. This is a goal. This is where you want to get. So what would I do if I was you at this point right now?
Put it in the front.
I would say, okay, let me expand this guy out. Use some FOIL. Y squared plus 9y plus 9y plus 81. Combine them. And I have it. So you may not be at this point. That's okay. Normal. Completely normal. Now this guy, if you can remember the pattern, it's a plus and a minus, right? Sum and difference. M squared minus 81. Multiply, multiply. X squared minus 16. What's 7f times 7f? Careful, careful. Think for a second. 49f squared minus 1. Careful. 4n times 4n. What is it? Good. Good. This one I think is a little bit easier to pick up. So I really want you to recognize this. We're going to need this guy in a couple classes. Yeah? Ready for your tries? Yes? Yes, we are. I'm going to just have you do a few of them, only because I want to make sure we get through everything. Okay. So I'm just going to circle a couple of them that I want you to do. If you get past these and want to do more, great. But do at least just those 4 right now. How are you doing? Anybody matching? Anybody's? Yes, sir. What's your question? You want to take it up here because you're not the only one that's going to have it. Which one? A? Right? So what you're going to do is you're going to expand. Right? We expand that guy out and then use either FOIL if that helps you remember what to do, or just remember multiple distribution. Distribute the x, distribute the 7. X times x plus 7 times x plus 7 times x plus 7 times 7, which is 49. These guys can be combined. If you're using the pattern, square the first one, right? Square the last one. Multiply those two things times 2. So where are we getting stuck?
I got that.
Where are we getting stuck? Yeah, if the pattern right now is too much, don't worry about it. Don't do the pattern. It's okay. It truly is okay if we're not quite ready for it yet. I'd rather actually see you get this practice using FOIL or multiple distribution. That's perfectly okay. And you might be next week you might say, no, I'm ready for this, and that's fine. Or never, I'm never ready for it. That's okay too. These though, I want you to know the pattern. How do we do with like F? I got it. G squared minus 11 times 11, which is 121, not 22, correct? Yeah. Be careful you're multiplying. 4h squared minus 81. 36k squared minus 64. 64p squared minus 9. Multiply the first and multiply the last. Yes?
Yeah.
Excellent, because we're ready for the big time now. We're ready for the show. Yeah, we're ready for the show. Okay, so, I don't know what that's to say when you go like baseball and you make it to the big leagues. Isn't that what they say? Because you're in the big leagues now. Now we get to revisit first, 3rd grade. Remember line division? Yeah, we're happy 3rd grade. Thank you. Remember the good old days? No. Okay. So, 3, how do you do this? If you look at you say, I'm going to break this apart. 3 times, you don't use the calculator. 3, ladies and gentlemen. 3 times what is 6? Isn't that what you said? 2. Now what if you didn't know that? I know you know that, but what are you doing? You're saying really 6 divided by 3, aren't you? 2. 2 times 3, right? Multiply step 6. And then what? Subtract. Now I know you know this. I want you to pay attention to this process. It's really, I'm trying to, because it's automatic for you now. I need you to really pay attention. So after you subtract step, we do a bring down. Then we begin again, right? You say 3 times something gives me 9. What's that something? 3. There's a long pause there. Then we do a multiply step. 3 times 3. Then we do a subtract step. Then we do a bring down step. 3 times what is 3? 1. Do a multiply step. Subtract, and here's my remainder. I hope this is not news to anybody. I was getting a little worried there, like, what? You subtract what? Right. Let's just another one with numbers. 729. Why is this hard? This is hard. 3rd grade. All right. Now this one, there is no even number, right? I can't come up with a perfect number. What's the closest number? 4 times what? What is the closest I can get? Multiply step, subtract step, bring down step. Repeat here. 4 into 32, there's 8. 8 times 4, multiply step. Subtract step, bring down step. Now I can't get an exact number. What's the closest I can get? 4 times what is 9? 2 times 4, 8. Subtract, and there's my remainder. Now in 3rd grade, they probably gave you a couple of options. 182, remainder 1. You remember that? Okay, that's for babies. For the first grade, you do that. All right, then they said, no. They put the little decimal and you start bringing down zeros. You keep doing this either forever or sometimes it ends, right? Or, okay. Anybody go to school outside of Virginia? Maybe you moved in here or something. Yeah, okay, maybe you remember this. Because I'm finding anybody who went to school in Virginia does not remember. The other way. See the remainder?
Yeah.
You put it over the divisor. You get 182 and 1/4. Those of you have state, have you seen that? Because nobody in Virginia apparently has.
I've never seen those.
Anybody else seen that before?
No.
We need to have a discussion with them about public schools and that area. Because that's usually what I do.
Oh.
Yeah.
Wait, does that work?
We never learned it.
I don't know. I have no idea. I'll tell you, New York, we're all over this. This is how we learned how to do remainders. So, we never learned it. You're learning it now. When you have a remainder, you put it over the thing you're dividing by, your divisor, and you get a nice little fraction. Yeah. But you're fine, you're good. That's the important point, that you can do that. I was a little bit shocked that we don't know this, but now we do. Okay, so now that going to look at it with polynomials. Now, here's the thing. It's the same process, which is why we kind of reviewed that a little bit. So here's how it works. You ready? Everybody find this on your paper so you can do the checking. Found it? You'll be fine. All right, so now you got to think about it. X times something gives me x cubed. Now remember, if you don't know what that is, you do a division. You say, I don't know what that is. What's x cubed divided by x, right? What is that? X cubed divided by x.
Squared.
X squared. Same base, subtract your x one. Come on. It goes up here. Same process, right? That means you do a multiply step. The x squared times the x. Then what? A subtract step. Then what? A bring down step. And then I repeat the process. X times what? Gives me 4x squared. If we can't see what that is just yet, you will eventually. Take that 4x squared and divide by x. 4x. Goes up here. Now we do a multiply step. 4x times x. Now if you're doing this right, they always match. Unlike with the numbers, these always work. Bring down step. X times what gives me 5x? 5. 5 times x is my multiply. Here's my remainder 0. So this times this. You think it's easier than the numbers? I do too. Now I will tell you this. I'm going to rewrite this another way. Is this equivalent to what I have here?
Yes.
Right? Doesn't fraction mean divide?
Yes.
Okay. So how does that work? Remember how the x applies to all these guys? So x cubed over x, 4x squared over x, 5x over x. I think this might be a little easier. If you're dividing by a monomial, this is easier, but I'm kind of proving a point here because we're going to be using this process in a moment, using something slightly different. So you can do this either way. You might find it this easier. Right? How do I know I'm correct? How do I know
Plug
I
it
got
back
it right?
in.
Plug it back in, what does that mean?
Add them back together.
How do I know that's right?
2 times
2 times 3, yes. So if you want to check, you take this and you multiply by that, and you hope that you get your original dividend. So x cubed plus 4x squared plus 5x, they match. So you can check them by multiplying back. Alrighty. I'm going to leave this for a moment because I think you get that. I hope. Because the next step here is dividing not by a monomial, but by a polynomial. Actually, a binomial. Now there's a bunch of words. Do this, do that, do this. Let's just walk through it. Now this one, be careful and make sure you're finding the right one. You see where it says divide polynomial by a binomial? There's like 3 bullets. And then it's like under there. Everybody find it? Because you got to do this with me. I'm telling you, you got to. But I don't have to listen, and I don't want to. Yeah, you're going to do this right now. Okay, we're right here. You're putting that down, and you're doing this. Okay? I need you 900%. Who's with me 900%? I'll accept 800%. You with me? Okay, block. No, you're with me. Here's what you do.
Whoa.
Okay. So at first, pretend the minus 1 isn't there. You look at the x, you look at the x squared. X times what? Gives me x squared.
X times x.
X. And how do I know that? Because I am going to do my multiply step back, but what am I multiplying by? Not just x. I'm going to multiply that entire x minus 1. I'm going to write it up here. This is what I'm doing. X times x minus 1. How do I do that? You don't know.
X squared
Distribute.
minus
X squared minus x. So x times x and x times minus 1. Notice how I'm putting these one on top of the other so they match. That's kind of important. That's your multiply step. Multiply gets the whole thing. What comes after your multiply step? Subtract. Now look how I'm subtracting, and you should be writing this on your paper. Put parentheses around it and subtract. Because what am I subtracting? This whole business. And again, I'm gonna write this long ways because you might be more used to seeing that. I'm gonna take this x squared plus 2x. That's this piece right here. And I'm gonna subtract this piece. So I just took what I have here, because I have to subtract it, and I'm writing it long ways, because we talked about what we do when you subtract. What do you do?
Oh, you distributed it.
Distribute the negative. So what's that going to do? It's going to make this a negative x squared, and it's going to make that a positive x. You getting this? Good. So, this becomes a minus x squared, and I will give you this little secret here. These should always cancel out. They will always cancel out if you're doing it right. If they don't cancel out, you can put the right thing up here. Now this minus x, look at it, it's 2x minus negative x. What's that? Plus x. Minus minus is a plus, and I'm just writing it here so I can see it. So that's like up here, that's like the 2x plus the x, 2x plus x. Well, what is 2x plus x?
3x.
And who followed so far? This is the trickiest bit right here, is playing with those signs. Okay? Question right now, anybody? Okay, now what? Put it down. Repeat. So you say, now I'm just looking at x. X times what gives me 3x? 3. Then I multiply that. 3 times x is 3x. 3 times negative 1 is negative 3, right? We're multiplying all the terms here. And then I do a subtract step. Now this one, look what I'm subtracting. Same thing. So what am I going to get? And there's my remainder. So when you multiply this in, this is what you get. How do I know I did this right? You can multiply that. Let's see. So I'll get my x squared plus 3x minus x minus 3. Combine the oid. Is this my dividend up here? Yes. Come on in. Anybody follow that at all? No. Okay, a little bit. I'm going to go just for a second to the U-try, because there's a good example there. I'm going to do A on the U-tries, just to kind of see it again. And if you didn't write that down, write this down, right? You've got to kind of go through the motions with it. So what are we doing here? You just look at the x and you look at the 3x squared. X times what is 3x squared? 3x. Then what? 3. Right? I mean, notice it did 3x squared over x. That's 3x. Yes, A on the U-tries. Now I'm multiplying back. 3x times x. And again, this should match. If it doesn't match, it's a mistake. Then I do 3x times negative 2. What's that? 3x times negative 2? Okay. Now I have to do a subtract step. Put them in parentheses. Do your subtract step. These will always cancel out if you've done this right. Minus, minus. What's happening here? Plus. That's a plus. I do write it up. I need to see it. So what's negative x plus 6x? 5x. And then I do a bring down. Right? Go again. X times what is 5x? Then I do a multiply step. 5x, 5 times negative 2. And then I do a subtract step. Well, 5x minus 10 minus the same exact thing is 0. So there I go. I'm done. Anybody in a place where they're like, okay, ish? You don't get it all? What's your question?
No, I don't like it.
Oh, I didn't ask if you like it. That's not a requirement. Not a requirement at all, but we have to be able to do it. Now I want to do another example. I'm kind of jumping around a bit, I know. But in the examples, I'm going to look at B. See if you can find this one. 2x minus 3, I want to divide that into this polynomial. You all see it? Because I want you to do it with me. So, same process. 2x times something gives me 2x squared. No, 2x times 2 is 4x.
1x.
So let's divide it and see what it is. 2x squared over 2x. There's a 1. X squared divided by x is x. That's x. So now I'm going to multiply that. X times 2x, I sure better do 2x squared. Good. And then x times negative 3. Everybody doing this? I see some people like jumping in there looking out the window. You will regret this when you get home.
I'll just ask my daddy.
All right, well. Wait, this one. Yeah, it's in the example section. So make sure you're in the right one. Bump back up to the example section. Yeah. Gonna do my subtract step. These always cancel out. Minus minus, that's a plus. 11x plus 3x.
14x.
14x, bring down. Minus 9. Go again. 2x times something gives me 14x.
7.
Plus 7, right? Multiply back. 7 times 2x. 7 times negative 3.
Negative 7.
Yeah, right? Subtracting where we get lost. Now this one is not just the same thing minus same thing. I got to think about it a little bit. These should always cancel out when they do. Negative 9 minus minus. So what's negative 9 plus 21?
11. And 12.
Oh. So this one has a remainder. So now we're going to go with the rule that the remainder becomes the 12 over your divisor, the thing you're dividing by. The only thing different from with the numbers is you have to kind of put this little plus here. It's understood with numbers that there is a plus there, but you have to be a little more explicit with the polynomial. Take the 12, put it over the thing you're dividing by. Done. So if you have a remainder, put it over the thing you're dividing by. Put your little plus here. You're adding it in. So you need to show that plus. And that is division of polynomials. So here's what I'm going to ask you to do. I want you to finish the examples we did not do in class. And I want you to finish right now. Homework. We're still in class. We're in school right now. We're going to do schoolwork. And I want you to do the other retries as well. You need to do this. Now here's the other thing. So what's today? Wednesday? I don't see you again until Friday, 8 o'clock. You're like, well, I do have a sore block on 7, so I'll just wait till 7 blocks to do this again. What do you think's going to happen if you wait till 7? Are there a lot of steps here? A lot of things? Please do ask. I know you're busy people. Please do some of them, at least 1 or 2 or 3 tonight, even if you don't finish the whole homework, which I'll give you a homework.
Okay.
But meanwhile, you know what you're doing. You're working. Yeah, I just want to make sure, these are the examples that we did. Answers. It's hard to read because mine scrolls on it. So if you work these, finish them at home, you can come back to either the video or the class summary page, or I just have these printed out. I'll see them. Video today, so I can look.
Yeah.
And there they are. So this one, please, I don't know how else to beg this. Please, do not wait like more than a day to look at this again.